Hey, class! Welcome to Polygons. We are moving on. Yes! First of all, what does the word polygon mean? It's just a fancy word for shape. To be more specific, a straight-sided shape. So a circle is not a polygon, but a triangle certainly is a polygon. Also squares, rectangles, hexagons, octagons, any kind of parallelogram, kites, trapezoids, etc., etc. If it has a bunch of straight sides, it's a polygon. Two other things to keep in mind. A regular polygon has all equal sides and angles. That's a lot of what we'll be dealing with in math class just because they're simpler. But there's all sorts of other kinds of polygons. One other thing to keep in mind, I didn't write this down, but this word convex. This is the kind of polygon that we're used to thinking about, like with a stop sign. It means that the polygon does not cave in anywhere. For example, this is a concave polygon, and a lot of different stuff applies to this. We're not dealing with this right now. Cool? Cool. So we're dealing with convex polygons. Sometimes we'll be talking only about regular polygons, but we'll get to that. Second thing to know, there's two tools we use mainly to calculate polygon angles or sides. The number one tool, there's classmates outside. Number one tool, the polygon exterior angle sum theorem. That's a lot of words for a really simple idea. The really simple idea is all exterior angles add to 360. Sorry, all exterior angles of a polygon add to 360 degrees, regardless of what shape it is. What? All the exterior angles of a triangle add to 360. All the exterior angles of a square or a rectangle add 360. You can easily think about that because squares and rectangles have 90-degree angles. 4 plus 90, because there's 90 on the exterior plus 90 on the interior. So all of the exterior angles of a rectangle are 90 times 4 is 360. That's actually true for all shapes. Hexagons, octagons, nonagons, decagons, dodecagons, that's 12 sides, etc. That's always true. Why? Because all shapes fit in a circle, and all circles have 360 degrees. All right, moving on. Polygon interior angles are a little more complicated. Let's do some math. All right, so let's do the math on that. Here's the closer look of the polygon, interior angle sum theorem. Here it is. The sum of the interior angles of any n-gon can be calculated by n minus 2 times 180 equals the sum. This sounds fancy, but n is just a stand-in for any polygon, where n is any number. All right, so fairly simple, right? Example, an octagon. Here, n equals 8. So I just put that in for n. 8 minus 2 times 180 equals the sum of the interior angles of this octagon. Sum equals 1080 degrees. Cool? Additionally, in order to find the measure of each individual angle of a regular polygon, regular, this wouldn't work for an irregular one, but for a regular polygon, just divide by n. That's 1080 divided by n. Keep in mind n equals 8, not 6, right? We subtracted 2 because that's what the equation says to do, but n does equal 8. And the measure of each interior angle of a regular octagon is 135 degrees. Finally, we can use this tool, actually, if given the angle sum, the interior angle sum, or even the individual angle, we can find the original number of sides. And we'll do that next. Okay, and then finally, Same principle, just slightly different. A polygon has an internal angle sum of 900 degrees. What is n? And here's the math. I just set n minus 2 times 180 equal to 900. Divide by 180 on both sides. N minus 2 equals 5. N equals 7. I hope you've enjoyed this video series on, polygons, and now we'll do a lot of practice problems. Thanks.